Alright, so as promised, I will be answering the sample exercises on a separate video, which is this one. But I hope prior to this video, you have already tried answering them on your own. Okay, so let's start with number one. Calculate the amount of water in grams that must be added to 5 grams of urea in the preparation of a 16.2% by mass solution. So if you haven't answered these problems yet, what you can do is, before I solve the problem, you can pause the video so you can try to analyze the problem on your own. Okay, assuming that you still don't know what formula to use, because most students might be frightened with chemistry problems, what you can do is try to read the problems twice and then try to find keywords. So let's try rereading number one again. Calculate the amount of water in grams. So you are asked to calculate for the grams of water that must be added to 5 grams of urea in the preparation of a 16.2% by mass solution. So the keyword here is percent by mass. So obviously, what formula you're going to use is the percent by mass formula. So that is equal to the grams of solute over the grams of solute plus the grams of solvent times 100. Okay, now try substituting the values. You were given the exact value for the percent by mass, which is 16.2%, equal to, what's the grams of solute? So try to analyze the problem. So the grams of solute here is the 5 grams. So over 5 grams plus the grams of solvent. So obviously the solvent here is water. So this is the solvent. So let's assign the grams of solvent as x. So x times 100. So the first thing that you can do here is remove the percent. And you can do that by dividing both equations by 100. So if you divide both equations by 100, 16.2 divided by 100, that is 0.162. This will cancel. So 5 grams over 5 grams plus x. So the equation looks more simple now. So from this point, we all know that the denominator of this term is 1. You can now cross multiply. So 0.162 multiplied by 5 grams plus x is equal to 5 grams. There you go. So what's the next step? You distribute 0.162 to the terms inside the parentheses. So 0.162 times 5, that is 0.81 grams, plus 0.162 times x, 0.162x, is equal to 5 grams. And then you combine like terms. So this term will now then be transposed to the right hand side of the equation. So 0.162x is equal to 5 grams minus 0.81. So 5 minus 0.81, that is equal to 4.19 grams. Okay, isolate x. How do you isolate x? You divide both sides by 0.162. So if you divide both sides by 0.162, so this side will cancel, and 4.19 divided by 0.162, that is equal to what? 25.86 grams. So the grams of solvent in this problem, which is water, is 25.86 grams of water. So problem number one is very easy. Now let's proceed to problem number two. Okay, calculate the mole fraction of hydrogen peroxide in a 20% by mass aqueous solution. Assume the solution is 100 grams. So what is asked from you from this problem? You are asked to calculate for the mole fraction of hydrogen peroxide. And you are given the percent by mass of the solution. So if the entire solution according to this problem is 100 grams, so the entire solution is 100 grams. So 20% by mass aqueous solution. So when you say aqueous, you dissolved your solute in water. Okay, so when you say aqueous, the solute is dissolved in water. So the other component of the solution is water. Okay, so let's try to write the formula for the mole fraction here. It's mole of hydrogen peroxide over the mole of hydrogen peroxide plus the second component is water. Why? Because it says aqueous solution, and when you say aqueous, it's dissolved in water. So here it says 20% by mass. So if the entire solution is 100 grams, what is 20% of 100 grams? That is 20 grams. So the grams of solute is 20 grams. And in this case, if the solvent is water, the solute is hydrogen peroxide. Very easy, right? So 20% of 100 is 20. Now, if the entire solution is 100 grams and your solute is 20 grams, how many grams is the other component? How many grams is water? So 100 minus 20, that is equal to 80. So the other component, which is water, is 80 grams. Now this is the formula. All you have to do is to substitute the values. However, in this case, the values are still in grams, so we still have to convert them into moles. So 20 grams of hydrogen peroxide, let's convert it to moles. Get the molecular weight of this compound. So in this case, hydrogen is 1.01, multiply that by 2. Oxygen is 16.00 multiplied by 2. This is 32, and this is equal to 2.02. So the sum is 34.02 grams per mole. Okay, grams per mole. So here you have to write the grams here. Why? For this to cancel, and then 1 mole of hydrogen peroxide. So how many moles is that? I'll write the equal sign here. So 20 divided by 34.02, that is 0.59. So 0.59 moles of hydrogen peroxide. Okay, very easy, right? Now let's convert the 80 grams of water into mole. So 80 grams of water. Get the molecular weight of the compound again. So hydrogen again is 1.01 multiplied by 2 because you have 2 atoms of hydrogen there. Oxygen, you only have 1 atom. So the sum of this is equal to 18.02. Okay, so divide by 18.02 grams, 1 mole of water. So the mole of water is equal to what? 0.02, 4.44 mole. Okay, now all you have to do is substitute these moles into this formula. Okay, let's write the formula again. So the mole fraction of hydrogen peroxide is equal to the mole of hydrogen peroxide over the mole of hydrogen peroxide plus the mole of water. Substitute the values. So the mole of hydrogen peroxide is 0.59 mole over 0.59 mole plus 4.44 mole. So the mole fraction is, let's type that in our calculator, 0.59 plus 4.44, it's 0.12. So the mole fraction of hydrogen peroxide is 0.12. There's no unit because mole fractions are unitless, because as you can see here, the unit moles cancels out. Okay, very easy. Let's proceed to problem number 3. How many grams of potassium permanganate are needed to make 100 ml of 0.250 molar solution? So you are asked for the grams of potassium permanganate. So we still don't know yet, assuming we still don't know yet what formula we're going to use. Try to reread the sentence and you're going to see this. It says molar, 0.250 molar. So that's molarity. And the formula for molarity is moles of solute over the liters of solution. In this case, you are given the ml of solution. That's very easy. You just have to convert the ml to liter. So let's try to write down first the what do you call this, the values given in the problem. So you have 100 ml of the solution, and the molarity was, the concentration is 0.250 molar. You're asked for the grams. If you get the moles of your solute, you can convert this to the grams of your potassium permanganate. So let's substitute first the values. You can either substitute first the values, or you can first manipulate the formula to get the term, the value that you are looking for. But first, let us convert this 100 ml first into liters, because in the formula it states liters. And how do you convert that? You simply divide the 100 into 1,000, and that is equal to 0.1 liter. So let's substitute first. You have the molarity. You have 0.250. In this case, I'm going to break this unit down into mole per liter, because molarity only stands for mole per liter. No? The capital M only means mole per liter. So let's write mole per liter is equal to X. Let's make this X to make it short. X over 0.1 liter. So how are you going to isolate this X? So what you can do is you can cross multiply. Okay. If you cross multiply this one, this becomes 0.250 mole per liter multiplied by the 0.1 liter. Okay? So what happens here, it's equal to X. There you go. So 0.250 times 0.1, it's the value, it's 0.025. 0.025 mole. Okay. So we got the moles of your solute, which is potassium permanganate. Now to get the grams, you simply have to convert it into grams. But first, you need to get the molecular weight of your potassium permanganate. So let's break the elements down here. So you have 1 atom of potassium, and manganese 1 atom too. Oxygen, how many atoms do you have? You have 4. Okay. Now, okay, the atomic weight for potassium is 39.10. You multiply that by that number. For manganese, it's 54.94, and for oxygen, it's 16. Now get the sum of this. So 39.10 plus 54.94 plus 16 times 4. Okay, so the molecular mass of potassium permanganate is 158.04 grams per mole. Okay, so this is 158.04 grams per mole. Now, all you have to do is convert this value into grams. So we have 0.025 mole of potassium permanganate. Okay? So below we write 1 mole of potassium permanganate. Why is the mole at the denominator side? Because we need to cancel the units. So times 158.04 grams. So the grams of potassium permanganate is equal now to 0.025 times 158.04. That is 3.95 grams of potassium per manganate. So in order to prepare a 100 ml of 0.250 molar solution, you have to dissolve 3.95 grams of potassium permanganate. Very easy. Now the next problem is just the same as this problem. So let's try answering that one. So here you're asked for the mass of sodium hydroxide. So what mass of sodium hydroxide do you need to produce 250 ml solution, 250 ml of 0.1 molar solution? So this is the concentration of your solution. It's 0.1 molar. So again, molarity. The formula again is mole per liter, mole of solute over liters of solution. So in order to get the grams, we first have to get the moles of solute. So let's do that first. So try to substitute again the value. So ml, we have to convert this to liter. So how do you convert ml to liter? You just divide it by 1,000, and that is equal to 0.25 liters. Okay? Now, okay, 0.250 liters. So substituting, we have the concentration, which is 0.100. Let's make this mole per liter is just the same. Mole per liter equal to the liter of solution. Let's assign x for the mole of solute, and then for the liter of solution we have 0.250 liter. So what you do here is you just simply cross multiply. So 0.100 mole per liter multiplied by 0.250 liter is equal to x. So this will cancel out, and 0.250 multiplied by 0.1, that's just only 0.025. So your x is equal to 0.025 moles. So in this case, our x is moles of solute and our solute is sodium hydroxide. Okay, so to get the grams of sodium hydroxide, we just need to convert it into grams because we're looking for the grams of sodium hydroxide. Okay, so first get the molecular mass of sodium hydroxide. So we'll break down the elements of the compound. This is 23.00. If you use 22.99 grams as atomic weight of sodium, it's okay. The difference is negligible. Next, oxygen, 16.00, 1.01. Okay, so the total of this is equal to 40.01. So 40.01 grams per mole. This is the molecular weight of your sodium hydroxide. Now we just have to convert this mole into grams. So you have 0.025 mole of sodium hydroxide, 1 mole of sodium hydroxide, and then 40.01 grams. So 0.025 times 40.01, that is equal to 1 gram. Yeah, you need 1 gram to create 250 ml 0.1 molar solution. Okay, so the grams of sodium hydroxide needed is 1 gram of sodium hydroxide. Okay, now we're on the last problem. So in this problem, you are asked, what is the mass of water? Mass of water in kilograms, so kilograms of water, needed to be added to 14.3 grams of sugar. Okay. To produce 0.0621 molal solution. So the keyword here is molal. And when you say molal, that is molality. And the formula for molality is moles of solute over the kilograms of solvent. So you are asked here for the kilograms of solvent. Okay. So let's try to substitute the values. You have the molality of the solution, which is 0.0621 molal. So molal or molality is just mole per kilogram, right? So mole per kilogram. It's equal now to the moles of solute. Were you given the moles of your solute? No, you weren't given the moles of your solute, but you were given the grams of your solute. So first, let's convert this 14.3 grams of your sugar to mole. Okay? So 1 mole. Get the molecular mass of this compound. So I'll break it down so you can be refreshed how to get the molecular mass of compounds. So carbon has 12 atoms, hydrogen 22, oxygen 11. Multiply this by their atomic weights. This 12.01, 1.01, and then 16. Now you get the sum. Okay, sorry, I pressed that. Let me type that down in my calculator. times 12 plus 22 times 1.01 plus 16.00 times 11. So the molecular mass of this compound is 342.34 grams. Okay, so here 342.34 grams. Now just input that in your calculator. 14.3 divided by the molecular mass, that is equal to 0.04 moles of your sugar. So that is your solute, your sugar. So here we write 0.04 mole of your sugar. And for the kilograms of solvent, which is water, we just assign X. So how do you manipulate this situation? Okay. Let me write this term again here. Sorry, I lack space. 0.0621 mole per kilogram is equal to 0.04 mole over your X. So what are you gonna do? How do you manipulate this? First, you cross multiply. So cross multiply. Okay. So 0.0621 molal, so mole per kilogram, times X is equal to 0.04 mole. Now, how do you isolate X? You divide both terms by 0.0621 mole per kilogram, or molal. 0.0621 mole per kilogram. So this will cancel, and your X now is equal to 0.04 divided by 0.0621. That is equal to 0.64 kilograms. Okay, so the mole will cancel here. So this is the kilograms of your solvent. Okay, so that's it. I hope you learned a lot from this video. If you want to master the calculations, my best tip would be try to find problems in the internet and try to solve one every night. One difficult problem every night, and your chemistry life would be much easier than you could ever think. Alright, stay safe, and I'll see you again on my next lecture.